Alright, so we're going to talk about sections 3.1 and 3.2. And the key picture for these is if I have two parallel lines cut by what we call a transversal. So M and N are parallel lines, and we know that with the little arrows that are shown there. And we have our line that goes through them, which we call the transversal. So we're going to use this picture all through this. Alright, and our notation is M parallel N if we use the two vertical lines to represent parallel. Alright, so we're going to have a bunch of really kind of three things in this lesson. One is a bunch of naming of angles. The second are some postulates and theorems that allow us, if we're given parallel lines, what do we know? And the third part is the converse of those theorems that we're going to talk about. So there's our transversal, the line that goes through the two lines. And then we have 5 names for types of angles that are formed. And the coplanar part deals with the non-skew. So these are assumed to be in the same plane. Alright, so we have alternate interior angles. So 3 and 5 are on alternating sides of the transversal, and they're between the lines, so they're interior. We call them alternate interior. Same side interior are, again, within the two lines, and on the same side of the transversal. Corresponding angles are a key type of angle, and they are on the same side of the transversal. One is interior and one is exterior. Alternate exterior are on opposite sides of the transversal and on the outside of the two lines. Same side exterior are on the same side of the transversal and on the outside of our two lines. So those are the names that we need to know. And the corresponding ones are going to be critical because they deal with our postulates. Alright, so we start with a postulate, and then we're going to get some theorems, and then we're going to turn them around for our converses. So the first one is that corresponding angles postulate. It says, if a transversal intersects two lines, then the corresponding angles are congruent. Well, remember a postulate, this is just like Euclid's fifth postulate that we talked about in class. And what it says is we assume this to be true, that if we have two parallel lines in a transversal, and the corresponding angles are congruent. So in our picture that's 1 and 6, 2 and 5. It's also 3 and 8, and 4 and 7. Alright, so from that postulate we get a bunch of theorems. And theorems are things that are going to need proofs. So we begin with theorem 3.1, which is the alternate interior angles theorem. So we have the interior angles. If we have parallel lines, then the alternate interior angles are congruent. We'll have a proof for this down the road. We also have 3 and 5 would be congruent, or 4 and 6, depending on which set of alternate interior angles we look at. Alright, if we have same side interior angles, then they're not congruent, but they have to be supplementary. So 3 and 6 have to equal 180, or 4 and 5 have to equal 180. And this makes sense if we start with a general picture where we had 90 degrees, perpendicular lines. We can see that they would be supplementary, or equal 180 degrees. If we rotated one down by 10 degrees, we'd have to do the same with the other, maintaining that relationship of supplement, so being 180 degrees. We also then have the alternate exterior angles theorem. Well, that says that the exterior angles have to be congruent if we have parallel lines cut by a transversal. And we can again go through proofs of those to determine to prove that these theorems are in fact true. So in our picture we'd have 2 and 8, and 1 and 7 would have to be congruent if we had parallel lines. Our last theorem for starting with parallel lines is the same side exterior angles, and these are supplementary. This is very similar to theorem 3.2. Alright, so supplement again is 180. So we have 1 and 6 are corresponding angles, and 6 and 8 form a linear pair. So therefore, 1 and 8 have to be supplements. Alright, because 6 and 8 are supplements and 1 and 6 are congruent. So we can substitute and find that 1 and 8 are supplementary. Alright, so here is a general proof for the alternate interior angles theorem. What we can look at is A is parallel to B, 6 is congruent to 8 because they're vertical angles, 1 is congruent to 6 because they are, this is for alternate exterior. 1 is congruent to 8 by our transitive property of equality. In general, if we have parallel lines cut by a transversal, we're going to have 8 angles that are formed, but only 2 angle measures. If we can look at the picture, because the vertical angles, those are congruent. And same thing with those. We have corresponding and vertical angles, which will make 2 sets of angles congruent. So if we're given in the picture that 42 degrees is one of our angles, we know that 1 has to be 42 because they're corresponding angles. And that 1 and 2 have to be supplementary because they add up to 180. Therefore, 2 is going to be 138 degrees. Alright, and given our picture, this is a very famous picture. It's going to help us prove the angles in a triangle are 180 degrees down the road. But we have 2 transversals cut by parallel lines. We have alternate interior angles, which are congruent 2 times. And we use the fact that A and C are known because they're alternate interior angles. And the A plus B plus C is 180 degrees because they form a straight line. Substitution and subtraction leaves us with, this should be a B. B is 75 degrees. Alright, well, what we're going to do now is turn these around. And opposed to having our theorem, we're going to look at the converses. So these actually, the converses are true, which are going to give us biconditionals, or if and only if statements down the road. So we begin with another postulate, which is our corresponding angles postulate, the converse of it. So we assume that if we have corresponding angles that are congruent, then the lines are parallel. So if we have that relationship, we know we're going to have parallel lines. We take the converse of the alternate interior angles theorem, which says that if the alternate interior angles are congruent, then the lines are going to be parallel. And again, we will prove these down the road, but we want to get them out there and understand what's going on with them so that we can use them efficiently. Alright, the converse of the same side interior angles, well, if they are supplementary, so if we have same side interior angles that are supplementary, they're not congruent, then the 2 lines are parallel. And if I have the converse of the exterior angles theorem, if I have alternate exterior angles that are congruent, the lines will then be parallel. And the last one is if I have supplementary same side exterior angles, then I know that my lines are parallel. Alright. We can use this fact to determine which of these, if any, lines must be parallel. So we're given 4 and 1 are supplementary. Well, those are same side interior angles, which means that lines ED and KC are going to be parallel. So we don't have any other information. We can't conclude that 4 and 3 are corresponding because we don't know about those horizontal lines being parallel or not. So all we conclude is that the vertical lines or semi-vertical lines are going to be parallel. Alright, for the next example, I'm given that m is parallel to n, and I want to figure out the value for x. Well, I know that from vertical angles, those 2 angles are congruent, and therefore those are corresponding angles and congruent. So I get this equation, 5x minus 31 equals 2 plus 4x, and solve for x to get 33. And so just to review real quick, the 5 methods that we have to prove lines are parallel. Well, I have all my theorems. I have my corresponding angles postulate. If they're congruent, then that's going to work. Alternate interior angles can be congruent. Same side interior angles must be supplementary. Alternate exterior angles are congruent, and same side exterior angles are also should be supplementary. If any of those are true, then we're going to know that we have parallel lines.